So let's talk about multiplying radicals. So whenever we multiply radicals, we're just going to do the same operation. Just remember, you cannot multiply inside the radical unless the radicals are the same. The radicands do not have to be, but the radicals do. So I'm going to use the full method since we have binomials times binomials. I got my first times my first. So now I have 3 square root of 5. Let me clean this up a little better. 3 square root of 5 times square root of 5. And I'm going to go ahead and put a plus sign here. Next, I'm going to take my outers. So now I have 3 square root of 5 times 5 square root of 7. And I'm going to go ahead and put my plus here. Now let's do the inners. I got square root of 7 times the square root of 5. And then our last. So now plus we have the square root of 7 times 5 square root of 7. And in multiplication again, we can combine just about anything together. The only rule that we got to follow here is that the roots have to be the same, not the radicand. So let's multiply. I see that I have a square root right here, and this is a square root. So that means I can take what's inside that root and multiply them together. And then we're going to bring down the 3. Well, I know that 5 times 5 is 25. Well, I know that that is square root 25. I know is 5. So now let's bring down the plus sign. Now let's look at it. We know that, again, the roots have to be identical, and it's a square root. So now we can go ahead and combine what's inside it. So I'm going to bring down my 3. I'm going to bring down this 5 because it's in front of it, and it's going to be multiplied to the 3, and I'm going to combine what's in the roots. So 3 times 5 is 15, and then 5 times 7, 5 and 7 both are prime, so we're not going to be able to take anything out of the root. Okay, so now let's look at this next part. I want to bring down the plus. Guys, watch the signs. If they're negative, you know that it's going to change everything up. So I see that I have a square root and a square root, so that means I can put everything together that's in the root, right? 7 times 5, well, those again are both prime, so whatever the product is, it's going to stay the same. And now let's go ahead and bring down this plus sign again, because there is no negatives to change anything. And I see that I got a square root and a square root being multiplied together. So that means that I'm going to bring this 5 to the front, and whatever's in the inside of each root, I'm going to put them together and multiply it. So that gives me a square root of 49, because 7 times 7. Well, I know the square root of 49 is 7. Do you see the pattern? If the root is a 2, which is a square root in this case, then it has to be a group of 2 of the same number. If that is so, then it factors out. And if you notice, it did the same over here on the 5s. So now I'm going to finish. 3 times 5 is 15. And I know that I have 5 times 7, and it's 35. These two are my like terms. So I'm going to come over here and rewrite 5 plus 35. And then if you look at the middle terms here, they both have a square root of 35. So they are like terms. So we can combine those as well. So that's going to be plus 15 plus square root of 35 plus square root of 35. So now let's combine them. We have 15 plus 35. So 5 plus 5 is 10. Carry the 1. 1 plus 3 plus 1 is 5. I have 15 plus 1. It's 16 square root of 35. And that is my answer by combining my like terms after we did the multiplication. So that is multiplying of radicals. Let's talk about dividing of radicals. Whenever we divide by radicals, we have this rule about division. You know, I've talked about this before, where you cannot have in the denominator, you cannot have 0, imaginary, a negative, a fraction. You cannot have a root, whatever type of root it may be. You can't have a decimal, right? Whatever it may be, you're not supposed to have a decimal. The only rule we cannot work with is the 0. The rest of them we can work with. And let's solve for this one here. I have the square root of 4. Well, I know what that is. That's 2. So let's go ahead and write it in that format. And it's all divided by the square root of 6 plus 8. Well, the square root of 6 will not simplify down, right? So we are stuck with the square root of 6. So this top, again, the numerator turned out really nice and pretty. So I'm going to have 2 plus 20, which is 22, all divided by the square root of 6 plus 8. I'm going to apply this rule. I'm going to have to multiply by its conjugate. And what do I mean by conjugate? The square root of 6 needs to go away. So if it's a positive on that end, then it's going to be a negative here. Okay, so now what I'm going to do is I'm going to distribute. So let's distribute. All right, 22 times a negative square root of 6, that's a negative 22 square root of 6. 22 times a positive 8, it's going to be a positive 176. Now let's do the bottom. The bottom says we're going to take the first times first. Well, that's a square root of 6 minus the square root of 6. So it's a negative, right? Because negative times positive is a negative. And that means I got square root of 6 times square root of 6. And then I'm going to say the positive 8 times the square root of 6. And then let's do the positive 8 times the negative square root of 6. And then we'll do the last, plus 8 times positive 8. So now we got a lot going on. Now we just got to clean it up. Well, this can be rewritten as 6 times 6 inside the square root, which we all know is 36, which what happens? If you notice the pattern, the roots are the same, right? And it's a square root, and there's a power of 2 when 6 is. So we know that power of 2 in the square root reduces down and leaves me with 6, the radicand. I'm going to bring down this negative sign, plus my 8 square root of 6. I'm going to rewrite this in a cleaner form. I'm going to bring that negative sign out to the front. Negative times positive is negative. And then I got 8 square root of 6. And then bring down the positive because they're both positive. 8 times 8 is 64. We're almost done. If you notice that we have a positive 8 square root of 6 minus an 8 square root of 6. Those actually cancel each other out and go to 0, and that's what we wanted. So now let's rewrite my math problem here. So I got negative 22 square root of 6 plus 176, all divided by negative 6 plus 64. So we're going to say 64 minus 6, and it gives me 58 in my denominator. We are almost done, guys. So the very last step is we need to see if it'll reduce. And in order to reduce, since we have this addition sign, it has to reduce with all 3 parts. So I need some number that will reduce by. Well, I know 22 is 2 and 11. So let's start with 2 because all 3 of those are even numbers. So let's start with 2. We know that 2 times, let me rewrite this right quick, guys. Get ahead of myself. All right, now let's rewrite it. 2 goes into 22 11 times. 2 goes into 58 29 times. 2 goes into 176 88 times. 11 is prime, 29 is prime, so we are done. They're not going to reduce any further, and that's what we want. And this is my final answer. So that's division of radicals. Thank you.